The unthinkable has happened. The mighty Crimean Bridge, Russia's symbol of power and connection, is in flames. How did Ukraine strike so deep, and what secrets lie beneath the surface of this massive structure? Stay tuned, this is the full breakdown you don't want to miss. Hello, everyone, welcome back to the channel, Global Times, USA. Please subscribe and like my videos. Today, I'm going to give you a full breakdown of Crimean Bridge in flames, Ukraine's strike. Examining not only what happened, but treating the bridge almost like a product. We're reviewing exterior, interior, or internal structure, performance, how well it held up, how the strike worked, safety, defenses, protection, unique selling points, why it was built, significance, price, costs, damage, and then wrapping up with a conclusion. Let's dive in. When you look at the exterior, the Crimean Bridge, also known as the Kerch Bridge, is a massive dual road and rail crossing that spans the Kerch Strait, linking the Russian mainland with the Crimean Peninsula via the Tuzla Island route. Its total length is about 19 kilometers, roughly 12 miles. Externally, it's impressive, long spans, piers rising out of the water, and a road deck above plus rails beneath or alongside. The bridge is a visible signal of connection, physically dominating the skyline across the sea. It was built with a large number of piers and deep underwater foundation piles to anchor it securely. The external appearance is also heavily fortified. Surveillance systems, anti-drone defenses, water barriers, underwater cages or obstacles in the sea around it, smokescreen systems, radar countermeasures, and protective measures are all part of the external shell. Over time, Russia has tried to beef up its external defensive envelope, adding underwater nets, submerged ships or barriers, acoustic sensors, increased patrols, and so on, to deter or detect intrusions. But as recent events show, those enhancements are not foolproof. Now moving inward, the interior, or better said, the structural heart and understructure of the bridge. This is the critical, deep, and more hidden part, and it's huge. Imagine hundreds of reinforced concrete piles and piers sunk into the seabed. The underwater foundations consist of bundles of pile groups that support each pier or support column. These carry vertical loads from the bridge deck and transfer them to the bedrock or stable strata below the seabed. Above those, girders, crossbeams, and steel reinforcement tie them together. The road deck is layered: a concrete slab, expansion joints, support beams, waterproofing, railings, and the roadway surface. For the rail component, there are rails, sleepers, ballast or slab track, and vibration dampers. There are also joints, shock absorbers, dampers, seismic features in case of ground motion or stress, and redundancy built in so that if some elements are damaged, the load can be redistributed to other structural paths. Under normal conditions, the interior is designed to be over-engineered. It must handle heavy loads including trucks, railcars, dynamic loads from vehicles, wind, thermal expansion, waves, currents, salt corrosion, and so on. The foundation piles are protected by sleeves or shells, and in many cases, protective casings or sacrificial layers to resist scouring or erosion by water currents. There may be internal inspection tunnels or spaces, not in a literal tunnel sense underwater, but engineering access routes so that maintenance crews can inspect structural joints, fix cracks, monitor corrosion, and replace components or reinforce parts as needed. In the recent strike, what Ukraine targeted was precisely this interior, the underwater foundations. According to reports, 100 kg of explosives equivalent in TNT were placed or already placed over time under the water, near key pile bundles or pier supports. The explosion was intended to displace or damage concrete piles under critical load points, undermining stability and cracking or shearing internal structural connections. In particular, it's believed the attack focused on mid-span abutments under the rail portion, or pivotal piers where stress is highest. Because much of that structural core is underwater and invisible, the damage is difficult to fully assess visually. It requires underwater surveys, sonar scanning, structural integrity tests, ultrasonic inspection, crack detection, and load tests. Because the interior is so vital, once those core elements are compromised, load capacity declines sharply. Even if the deck or road surface appears intact, hidden shifts, microcracks, or foundation displacement can weaken the overall stability. Plus, secondary damage may propagate, cracks may widen, reinforcement bars get exposed to corrosion, adjacent elements take extra stress, etc. The repair is extremely complex. You'd have to drain sections, do underwater concrete injection or replacement, possibly jack up segments, rebuild pile bundles, retention reinforcement, and ensure everything realigns. That kind of repair can take months and millions. So in the interior breakdown, this strike shows that even a seemingly indestructible structure has its vulnerabilities. The parts you can't see are often the most sensitive. Moving on to performance, how well the bridge held up and how effective the strike was. Before the strike, the bridge's performance was stable. It served as a major logistical artery, carrying both road and rail traffic, civilian and military, freight and personnel. But it also had a strategic burden. It was under constant threat, requiring continuous monitoring, repair, and reinforcement. The design tolerances likely allowed for some wear and occasional small damage from storms, corrosion, minor impacts, but large deliberate damage was not fully anticipated, especially underwater sabotage. In the recent strike, reports suggest the explosion occurred around 4:44 a.m. local time. Ukraine claims it mined supports over months and detonated undersea, severely damaging piers. After the explosion, Russian sources temporarily closed the bridge for inspection roughly 4 a.m. to 7 a.m., then reopened it, claiming minimal damage. That suggests either the damage is not catastrophic but hidden, or that the reopening is premature for propaganda reasons. Analysts say that the damage is not always obvious from above, and that internal stress or compromised foundations may manifest later. Thus, the performance under stress is being tested now, and so far, it has survived a major blow, but with questionable integrity. This strike reveals a dual narrative: external resilience, bridge still standing, and internal fragility, foundations compromised. Over time, even if traffic resumes, hidden damage might cascade into structural failure or force weight restrictions or partial closure. Now, safety features: what protections were in place and how they fared. From the start, the bridge had multiple layers of defense: cameras, radar, anti-drone systems, patrol boats, underwater sensors, sonar, nets, submerged barriers, acoustic detection, and anti-intrusion systems. These were meant to detect aerial drones, water drones, divers, small boats, or tampering. Also, smokescreen generation, radar jammers, and other electronic countermeasures were reportedly used. Russia also sank dummy ships or obstacles to obstruct underwater drones or submersibles, and placed nets or steel cages around piers to act as sacrificial buffers. Despite all this, the strike likely bypassed many of these because the attacker struck under the waterline, where defenses are weaker or more complex to maintain. One safety design principle is redundancy, multiple structural load paths, so that if one support fails, others pick up the load. That redundancy likely prevented immediate collapse. Another is overcapacity, building more strength than needed, so unexpected damage still leaves margin. Also, periodic inspections and maintenance help detect stress or corrosion before failure. But sabotage attacks, especially underwater, are inherently harder to defend because water conceals, noise is muffled, and direct line of sight detection is limited. The protections are limited by technology, cost, and coverage area. So while the outer safety defenses exist, they were insufficient to prevent the strike, showing that no defense is perfect, especially for vital infrastructure in a war zone. Let's consider unique selling points, or in this case, unique strategic and symbolic features of the bridge, what made it so important, what justified its construction, and why both sides cared so much. First, Connection. The bridge physically links Crimea to Russia, enabling ground transport of people, goods, supplies, military hardware, and fuel. It reduces reliance on ferries or sea routes, which are slower, vulnerable, and less reliable. Second, strategic logistics. For Russia, the bridge was a backbone for supplying troops in southern Ukraine, moving heavy armor, ammunition, fuel, and reinforcements. Third, symbolic value. Building the bridge was a prestige project for Russia, reinforcing its claim over Crimea after the 2014 annexation. It signified permanence, control, and engineering prowess. Fourth, dual functionality. Combining road and rail enables flexibility. Fifth, deterrence and psychological impact. The bridge is a target, but also a statement that Russia is anchored to Crimea and will maintain continuity despite conflict. Sixth, resilience and engineering challenge. Constructing a long sea crossing over a strait with strong currents, deep seabed, environmental stress, and sheer scale is itself a feat. Those features made it both a valuable asset and a prime target. In short, its uniqueness lies in its strategic, logistical, and political significance. Turning to price the cost to build, maintain, and now repair, and also the cost inflicted by the strike. When the bridge was built, the estimated cost was large. Reports vary, but estimates include around 227 billion rubles $2, 3 billion at the time, or other estimates around $7 billion for the entire project. Over time, maintenance costs are substantial. Inspections, corrosion control, repairs, structural upgrades, defense systems, underwater protection, surveillance systems, etc. Now for damage, the strike likely caused millions or tens or hundreds of millions in repair costs, not only for immediate structural repair, but also for long-term reinforcement, safety upgrades, replacement of damaged piles, underwater concrete remediation, and possibly weight restrictions or closure costs. Add to that the economic impact, traffic interruptions, delays, supply bottlenecks, rerouting, military and civilian disruption. These indirect costs may far exceed the direct repair bill. So the bridge's price is not only its original construction investment, but its ongoing cost burden and now the penalty paid by damage and risk. Finally, in conclusion, what does this all tell us? What is the takeaway, and what future we might foresee? This review of Crimean Bridge in Flames Ukraine strike shows how even the mightiest infrastructure, one built as a strategic anchor, can harbor vulnerabilities, especially hidden internal ones. The exterior shell, impressive as it is, can mask structural weakness below the waterline. The interior core, the foundation, the underwater piles, those are the hidden heart, where sabotage hits hardest. Performance under stress so far has shown resilience. The bridge did not collapse, traffic reportedly resumed, but that may be deceptive. Hidden damage may impair long-term stability. Safety measures, though layered, have blind spots. Unique features gave the bridge its value, strategic role, and symbolic weight, making it both indispensable and a prime target. The cost of building and maintaining such infrastructure is enormous, and the cost of damage in a war zone can be astronomical, not just financially, but in strategic disruption. In the end, the strike underlines that in modern conflict, infrastructure is not merely passive backdrop, it is active terrain. The ability to disable critical nodes, undermine foundations, and strike at the hidden core can turn powerful assets into liabilities. For Russia, the bridge remains essential, but its vulnerabilities are exposed. For Ukraine, the strike is tactical, symbolic, and strategic all at once. The balance now depends on whether the bridge can be repaired, reinforced, and defended well enough to survive further blows, or whether it gradually becomes unstable, restricted, or unusable. That wraps up my deep breakdown of this event, as if the bridge itself were the product under review. If you found this insightful, don't forget to hit like, subscribe, and share. I welcome your comments and thoughts. Do you think the bridge can be saved, Or is this the beginning of its end?